Good morning and welcome back. So today we are starting new task or webinar series. We are talking about to evaluate pore pressure with logs for to make quantitative analysis of fracking service and risk assessment. This is a new trend approach that complete holistic approach that is comprehensive of various types of logs techniques, and the logs techniques are really function to evaluate the fracking method service and also the risk assessment, and it makes the works in the company really safety and much more less expensive. So what does it mean? We are starting to an academic approach to evaluate the pore pressure before the fracking service. The pore pressure is the hydrostatic and lithostatic condition around the wells. So the key points, the first question is understanding what does mean pore pressure. After we can choose the selected logs to predict pore pressure and obtain corrected data. We have also various methods to fracking, and we can make also quantitative analysis to these kinds of approach. We applied this in different case study for oil and gas, but also for geothermal reservoir. Today we are focused to underline what does mean pore pressure. We can consider pressure as study pore pressure in different way. Distinguish, for example, between the diagenetic pressure and the internal water pressure in plastic and sediments. You can see also another image that we can show you that the pressure was recorded in sediment. We change, we represent the history of change of this kind of sediment. So you can record the state, the transient flow, the compact sediment and the steady state flow below. It is the three type of pressure, with the depth in this case that represented the diagenetic pressure. But after in the static condition, when we have just realized the wells, you need to study the pore pressure. We can consider this pore pressure and analyze this phenomena with different approach, physically, mineralogically, and make instant image situation with accurate logs and correction. So start to make comparison between this image represented clear the genetic phenomena and how they create the pore and the pore pressure. So for example, for a complex geological ambient like sediments bar like this, you can have different type of pressure, compactation, cementation, dissolution, and also you can study also the grain size, for example, for gamma ray and NMR logs or like this. But when you are realized a well, before you want to simulate, for example, and creating fracture project, you need to study the pore pressure. So to study the pore pressure, it means in this case we have a table of a comparison that make an application to evaluate different fracking methods studying the pore pressure. So it's clear that the pore pressure is too different between carbonate rocks and sediment rocks. So in this way we are a clear example of pressure in a small section of terrain. You need the pore pressure, that is the pressure that can make capillary phenomenon like this, and the vertical effect stress that is contrasted by the total geostatic load. But instead of this, these effects is more complex in a reservoir, and if you have, for example, analyze the reservoir, you can do, for example, for sonic log of seismic acquisition, For you need different curves of differential pressure, for example, for recrystallized dolomite, like with this kind of porosity, or you can have also the well cemented grindstone with intra-frame pores. So to evaluate this kind of phenomenon of pore pressure in carbonate rocks and in sandstone rocks reservoir, you need to make some model with primary porosity origin, study primary porosity origin, intercrystalline bug and fracture, the pore pressure build-up mechanism, typical hydrostatic gradients, and sonic logs response to the pore pressure, weak to nonlinear lithology and bugs. The density log response, sometimes small change density dominated by mineral matrix, strong captation related to decrease in density under pore pressure. In sandstone, lower density indicate overpressure in carbonate mineral change. The resistivity response, high may decrease in fracture overpressure zone, lower in shallow zone like variable in sands. So this implication for pore pressure evaluation, and especially for fracking, that means that for carbonate response sometimes we have less compactation. So when we have less compactation, the pore pressure is not easy inferred from porosity and viscoelastic model. That means that they can derive the different type of fracture, especially with explosive fracture like this. For carbonate often located in overpressure zone, and sandstone show regional compactation related to overpressure. So that means, for example, the fracture system is much more influenced by the pore pressure and the log density analysis that can reveal this. After this kind of consideration, you can have a table of comparison and application and evaluate fracking methods. For the first, you can need to evaluate pore pressure when pressure expected by fluid, water, soil, and gas with pore space of rocks. The diagenetic pressure can be also analyzed, and the pressure generated internally during the mineralogical change, because you can make like an inaction, you can enact also a diagenetic pressure affecting sandstone reservoir. Both influence affective stress, rock brightness, and fracture initialization. So what kind of measurement method you can apply for this? You can use a different type of well test like MDT, FT, sonic log, density log, and also estimating by other previous data like drilling data or weight analysis. Depth fluencies, the pore pressure increase with depth to fluid loading and compactation. Instead of this, the diagenetic pressure dominated in deeper buoyant zone around 2-3 kilometers where mineral reactions are active. So which can be the effects in sandstone reservoir before evaluated method of fracking. Combined evaluation is crucial for prefracture stress modeling and selecting fracture stage. At value depth of reservoir for a sandstone reservoir, you can have different diagenetic pressure that can make evaluate and register according to the pore pressure, leading to underestimation of fracture gradient. So about this is a complex analysis that you need to do with really attention for do safety tasks, safety jobs in this case, and reduce cost of security and cost of operation. The table of comparison and application evaluate fracking methods. In this case, we have some parameters that you need to consider and to put on. The impact on effective stress. So pore pressure reduce effective stress as pore pressure increase. Which kind of will be the effects in sandstone reservoir? We can have, for example, a misinterpretation can cause incorrect factor initial pressure precondition. So if you are not evaluate the correct pore pressure, you can have a misunderstanding in pressure of injection of during fracking operation. The relation to rock mechanics, directly influenced by fracture pressure, leak of test, and the genetic overpressure may require high hydraulic energy for fracture initiation. Another parameter is the effect of permeability. Elevated pore pressure maintains open microfracture and increasing permeability temporality, but the permeability is only can change in the time, and it can decrease really fast in this case. So the effect on permeability is really to understand too important to adapt the captive wells for a long periods. So impact fluids for flow efficiency during hydraulic fracture and production recovery. The ductility of logs, abnormal sonic transient time, density neutron separation, or resistivity drops. That means they have some effects. Logs interpretation, for example, you can have a not real value of logs because if you are not considered the hydrostatic pressure and recorded the pore pressure in a correct way, you can have a logs interpretation must be different between fluid overpressure and cementation effects. So the prefracturing implication must be accurately defined to the sinus safety and mud weight and fracture gradient. Combine pore pressure and diagenetic pressure control frac, propagation geometry, and fracture height growth. Overall influence, dynamic and variable can change with production of injection. So the overall influence is important by it depends also we have a jointly defined mechanical and hydraulic behavior of the reservoir before stimulation. So it's clear that you can change the mechanical and hydraulic behavior if you are not considered these effects of pore pressure in choosing the fracture and pressure of fracturing. We have a table of comparison and application in evaluated fracture methods, direct drive of fracture propagation, fracture height growth and loss risk. So why is it matter for pore pressure? You have several parameters and indicators. For example, for sonic logs and whoopee anomalies, you have a fast indicator of overpressure like this, and you have several also implications for fracturing and recommended adjust. In this case, when we have abnormal values of sonic logs and whoopee anomalies, generally we have in carbonate, we have a noisy carbonate requires multi-log cross-check with the also image log, and through all uncertain pressure prefer diagnostic frac. For example, you can use mini frac or deep frac. You need also to consider all other several parameters. You can have a list of parameters that you need to consider and how to measure also. You need to measure, for example, for micro image scanner, when we are considered natural factor just present in the rocks. We can control the complex basis planar fracture propagation. We can do for FM boreal image, so televiewer, but it's clear that may show open vagues and complex natural fracture for a limited volume. The typical behavior, for example, is change between the sandstone reservoir and other type of reservoir like also carbonate reservoir like this. So the problem is to study really with attention these parameters and investigate it with multiple types of logs before to have a complete photography of geomechanical and physical parameters, and also to have a clear understanding of the possibility effects. For example, another parameters you need to consider is the leak off of the fracture pressure, because you can have an important implication that use the DTF derived closure stress for this design. For carbonate, you may need acidification or fracturing of triacid propant triners where natural fracture domains. Is not so easy sometimes because you need much more acquired data in multiple time. We are trying to create an internal procedure to standardize our parameters and acquisition. Take attention of it's clear that the importance of this part is to take attention for safety factor jobs and economic project evaluation. You map concrete risk on making fracking without this kind of analysis. You have between 4 levels of risk that you need to consider, for 0 to 3, from low risk to high concern risk, when you are difficult condition to access with logs and make a diagnostic test, or when just is the hold wells with some trouble in casing or bond, and calculated total risk score. In this case, we have also a value to calculate the total risk score, 0 to 10 standard. We can say that it is a standard propant based fracture slicker or close slicker, like is appropriate. When we have a high value between 11 to 18 with modified fracture limited entry, the stage diversion, high property, low rates. To 18-20, the diagnostic problem is the mini-frac core review, and we consider also in this case this table is also linked to the type of fracking you can apply. For example, if you have a security, if you evaluate the safety condition of wells and you have a medium pore pressure, you can build up a table of application of fracking. That is a summary of knowledge in this case. So for a safety, you can consider all geomechanical parameters, and you have a diagnostic problem. Applying first the scan microimaging after starting with mini-frac core review, and consider acidizing hybrid acid or alternative stimulation. It's clear that you can do all of this in step by step, or in task by task, and step by step. When you have a wells is built up in around the last 10 years, and you have evaluated the stability and rock stability, bond stability. So for old wells, for real old wells, wells is built up between 20 to 13 years ago. You need to make a really attention evaluation of risk. So evaluated also the condition of cemetery bond and other areas. So the analysis is much more complex and you require more time in this case. But we can discuss in a deep way in a second part of webinar. We are make a focus, for example, for old wells, how we can apply fracking and evaluate the fracking assessment in old wells using these matrix parameters. So this is the first staple for fracking assessment evaluation through pore pressure evaluation and logs, which will be the much important risk to take under consideration. Uncontrolled fracted height growth, but it's too easy to understand which will be the maximum extension of fracturing. You need to make a volumetric geomechanical analysis estimated with sonic logs, density logs and image and microseismic analysis. What to look for in a pore pressure evaluation? You need to evaluate the low Sherman margin below the target and what kind of prevention and mitigation action you can perform before starting fracking. Reduce the net pressure, lower pump rates using limited entry and stage isolation, place strafe barrier, and like this. So another risk is to loss of containment and communication to acid adjacent formation. So it's not so recommended because you are wrapped in the normal barrier that you can have, and so the mechanism of fracture connect to different, for example, different height of reservoir can be also really dangerous. Isolated intervals, Parker and casing can be actual, can be make in action. User low volume stage, user diversion agent, pre-job mini frac, like this. Another risk is the server fluid loss circulation, inducted seismic fault reactivation. You can have also this kind of risk, fault reactivation. Another risk is to unweighted cross-flow aquifer contamination. The last two risks that you need to evaluate is the kick well control event during simulation and complete stage coverages with insufficient. So this is a clear table of risk assessment that you need to evaluate before the pore pressure. So this is the first table, and today we are stopping here for the first part of the webinar series. In next days we are to start to explain why use some predictive logs to predict the pore pressure. It is another fundamental question to study this kind of project, and in a special series we are also discuss the matrix risk, the matrix table to apply different types of fracturing in different type of project, because you can have, for example, ancient wells is built up 20 or 30 years ago that is not It's not to say that we can not apply fracturing, but you need to evaluate the condition of wells, the cemetery bond, and like this, so it's too complex, instead of the wells that is built up in the last 10 years. Thanks for attention, and see you in next days.